Hi, we're in San Francisco. People have come from all over today to watch the Blue Angels perform. But we're here today to do some Carpool chemistry. Today, we're going to learn about electron configuration notation, orbital notation, and electron dot structure. In a previous episode of Carpool chemistry, we drew the planet diagram for chlorine, which had 17 protons and 17 electrons. This planet diagram showed the relationship between energy levels, sublevels, orbitals, and electrons. Even though it's not exactly how it looks in real life, it just shows the relationship between those parameters. The planet diagram is fine, but it is kind of cumbersome. It's a good visual way to see it, but once you understand that, there's got to be a faster, easier way to express the same information for the electrons in chlorine. Enter electron configuration notation. So what you do is you take a look at the first electrons that we placed. What main energy level are they in? They're in the first energy level, so you put a 1 on your paper. What sublevel are they in? They're in the S sublevel, so you put an S. And how many electrons are there? There are 2 of them, so as a superscript, you put a 2. That takes care of these 2 electrons in the first energy level. Let's move on to the next ones that we placed. What main energy level are they in? They're in the second energy level, so we put a 2. What sublevel are they in? They're in the S sublevel. And how many are there? There are 2. We put a 2 as a superscript. Moving on to the next set of electrons. What main energy level are these in? They're also in the second energy level, so we write down another 2. What sublevel are they in? They are in the P sublevel this time, so we put a P. And how many total electrons are in this second energy level, P sublevel? There are 2, 4, 6 of them. So we have 2p6. Let's move on to the next set of electrons that we placed. They're in the third energy level, so we put a 3. They're in the S sublevel, so we put an S. And there are 2 of them, so we put a 2 as a superscript. And finally, our last electrons that we placed, they're in the third energy level, so we put the 3. They're in a P sublevel, right over here. And how many are there? There's 1, 2, 3, 4, 5. 5 electrons. So we put a superscript of 5 there. And this is our electron configuration notation. Now the orbital notation is similar. It's kind of like between the electron configuration notation and our planet diagram, where it's partly visual too. So what we do on orbital notation is we use a series of lines and arrows to represent the electrons in orbitals. For example, our first set of electrons are once again in the first energy level. They're in the S sublevel, and there are 2 of them, and we represent those 2 electrons with 2 arrows. An arrow going up and an arrow going down to represent opposite spins. And this line here indicates that they are in an orbital, much like this circle indicates that they're in an orbital. Let's take a look at the next electrons that we placed. They are in the second energy level, so you put a 2. They're in the S sublevel. And how many orbitals are there? There's 1 orbital, so we have that 1 line representing the orbital. And we have 2 electrons inside there, 1 up, 1 down. Once again, representing opposite spins. Up is opposite of down. The next electrons are in the second energy level, P sublevel, and how many orbitals do we see? 1, 2, 3 of them. So we have 3 lines for our 3 orbitals. They're in the second energy level, P sublevel, and each of them have 2 electrons inside. But notice, out of good habit, I put 1 in each first, and then I double up. Even though in this particular instance, it comes out to be the same, I do it out of good habit. The next set of electrons are in the third energy level, S sublevel. There's 1 of those orbitals there. So here's that line for the 1 orbital. We have third energy level, S sublevel, with 2 electrons inside, one arrow going up, the other arrow going down. And our final set of electrons are in the 3rd energy level, p sublevel. And we have 3 orbitals there, so 3 lines, 1, 2, 3. And these are 3p orbitals, 3p, 3p. And then once again, I put 1 in each first, and then I double back with the 5th and the 6th electron. And that's your orbital notation for an atom of chlorine. And finally, the one that is the shortest to do, and it deals with the electrons in the outer energy level. Let's write that down. Outer energy level electrons. And so what we do is we write the symbol of the element, chlorine in this case, and we place dots around the symbol representing only those electrons in its outer energy level. Let's take a look. The outer energy level here is the 3rd energy level. And how many total electrons are in the 3rd energy level? Let's count them. 1, 2, 3, 4, 5, 6, 7. So we need to place 7 dots around this symbol for chlorine. Now, do we just put them anywhere we want, or is there a certain pattern that we should follow? There is a certain pattern. Here it is right over here. For any element X, the first electron would go here, the second over there, 3rd, 4th, 5th, 6th, 7th, 8th. So for chlorine, our first electron would go right over here, the second electron down over here, the 3rd electron up over here, the 4th electron down there, the 5th electron here, the 6th electron's there, and the final 7th electron is right up over here. And as we'll find out later, this electron dot structure is very important because it's those electrons in the outer energy level that play a pivotal role in chemical bonding. So that's how you draw electron configuration notation, orbital notation, and electron dot structure. From San Francisco, California, this is Carpool Chemistry. Thanks for watching.